We're told that inverse demand in a good period for wheat is given by P equals 10 minus 0.01 Qg. And in a bad period is given by P equals 10 minus 0.02 Qb. The marginal cost per bushel of wheat is constant at $2. Then it goes on to tell us some information about a forecast we received for the last 20 periods. And we'll deal with this information in a second. First, let's take a look at the question. The question is asking, what is the value of the forecast per period, assuming that the last 20 periods indeed comprise an appropriate sample from which to extrapolate probabilities? So let's organize all these sentences in this last paragraph into a nice table to help us organize our thoughts. Well, the table is going to have demand on top, and demand is what actually happened. We either had a good period or a bad period. On the left side of the table, we're going to put our forecast. We could have either had a good period predicted or a bad period predicted. So let's read that paragraph and fill out our table. 11 times the forecast correctly predicted a good period. So the prediction was good and demand was actually good, which is the top left corner of the box. And we see we put an 11 there. 3 times the forecast predicted a good period, but demand turned out to be bad. So we're in the top row because we predicted a good period, but demand was bad, so we're in the right column. So the top right corner of the box, we put a 3. 2 times, the forecast predicted a bad period, but a good period occurred. So we're in the bottom row because we predicted a bad period, but we're in the left column because demand was actually good. So 2 goes in the bottom left corner. And the rest of the times, the forecast correctly predicted a bad period. Well, there's 20 periods total, and so far, we've had 11 plus 3 plus 2, which is 16 predictions. So the rest of those times must equal 4, 20 minus 16. So 4 times we predicted bad, so we're in the bottom row, and demand was actually bad, so we're in the right column, which is the bottom right corner of that box. Now that we've filled out our table, we're going to use this in a second, but first let's look at what the question's asking again. It's asking about the forecast and the value of that forecast per period. Well, we know that the value of information is equal to the expected profit given information minus the expected profit with no information. The easiest step and the first step we'll do here is to solve for the expected profit with no information. And when we do this, we can cover up our whole left side of the table, the prediction side, because the prediction side is information. So with no information, we're not concerned with that at all. We're just concerned with actual demand, whether it was a good period or a bad period. Filling out our profit function, we're going to use 13 divided by 20 as the probability that we have a good period. And that is because we can add our actual good periods. 11 plus 2 is 13. So that is the probability that goes with our good period information, which is an inverse demand in this case. The 7 out of 20, or the 3 plus 4, is the probability we'll have a bad period. So that's going to be the probability that goes with our bad period information. And now, this is something that you have to make sure you understand. We only subtract the marginal cost times the quantity in a good period. We know that either a good period or a bad period is going to happen with some probability of each. We also know that the amount that we plan to sell in a good period should be greater than the amount that we plan to sell in a bad period. So we're going to prepare our marginal cost accordingly. So the constraint is QG must be greater than QB in order for this to make sense. If the constraint is broken, we have to replace all the QGs and QBs with just Q. So we'll take the derivative of our profit function with respect to QG, and we'll solve for QG. We'll take the derivative of our profit function with respect to QB, we'll solve for QB. We'll check our constraint to make sure that QG is indeed bigger than QB. If our constraint is not broken and QG is bigger, then we just go back and plug in QG and QB everywhere we see it, and we get a number for the expected profit with no information. If, however, the constraint was broken, we'd have to go substitute Q in for everywhere we see a QG and QB and do the whole process over again. So now let's look at the expected profit given information. Well, it's going to be broken down into a couple steps. First, we know that the expected profit with info is equal to the probability that we get good news times the expected profit given good news, plus the probability that we get bad news times the expected profit given bad news. Let's first solve for the probability that we get good news and the probability that we get bad news. When we're doing this, we can cover up the demand side of our table because we're just interested in our prediction side. And the probability that we get good news, well, how many times did we get good news? 11 plus 3 times, or 14 out of 20 times, we are expected to get good news, which means 6 out of 20 times is the probability that we've gotten bad news. We're going to visit this equation later, but first we have to solve for the expected profit given good news and the expected profit given bad news. So that's what we're going to do now. When solving for the expected profit given good news, we can cover up the bad news row because we're assuming that we indeed did get good news. So out of the 14 times we've gotten good news, how many times did we have a good period? 11 out of 14 is the probability, given good news, that we actually have a good period. So that's the probability that is linked with our good period information. 3 out of 14 times, given that good news, we actually had a bad period. So that's the probability linked with our bad period information. And again, the marginal cost is only linked with the quantity we plan to sell in a good year. For the expected profit given bad news, we're going to cover up the good news row because now we're assuming that we have in fact gotten bad news. So we've gotten bad news 6 times, and 2 out of those 6 times we actually had a good period. So that's the probability that's going to go with the good period information. 4 out of 6 times we actually had a bad period. So that's the probability that's going to go with the bad period information. And again, the marginal cost is only linked with the quantity we plan to sell in a good period. For both of these steps, we're going to do the derivative of each profit function with respect to QG and with respect to QB, solve for QG and solve for QB, and we're going to make sure that we check our constraint, that QG must be greater than QB. The expected profit given good news, this won't be a problem because the chances of a good period given good news are very high, 11 out of 14. However, the expected profit given bad news, this constraint is probably going to be broken. Now you want to go ahead and check it for yourself because your numbers are going to be different, but usually this is going to be broken because the probability of given bad news of having a good period is so low, only 2 out of 6. So if that constraint is broken, again, we have to go back and replace QG and QB with just Q. And in our case, we expect that the expected profit given bad news, we will find the constraint is broken, so this is what our profit function will look like when we go back and substitute just Q in everywhere we see a QG and a QB. And we're going to solve for a number for each of those expected profits. The expected profit given good news is just going to solve down to a number, and the expected profit given bad news is just going to solve down to a number. We can now go back to our expected profit given information and plug in those two numbers where we see here. After we've done that, we have a number for our expected profit given information, and we're ready to answer the main question, which in this case was, what was the value of that information? Plugging in our expected profit given information and our expected profit with no information, we'll arrive at our answer.